So this is continuation of section 2.4. It's called 68, 95, 99.7 rule. You will know what that means in a second. Remember, guys, when we talked about the shapes of histograms the other day, I showed you 4 shapes, which I'm going to show them to you one more time. I said, when you graph, just data sets, you could get a shape like this, which is called symmetric or bell-shaped, distribution. The mean, median, and mode are all in the very middle, and they are all exactly the same. Or you could get something like this, and I give you an example. This is called uniform. You could get a data set that is skewed to the right, which is called the right tail distribution, or skewed, sorry, this is left tail. This is skewed left distribution, or you could get a skewed right distribution where the tail points toward the right. But I told you that the most common distribution histogram is the bell-shaped, which looks like, just a bell here. That's what we call it, a bell-shaped distribution, which is the symmetric distribution. So this is what a symmetric distribution is. If I give you a data set and you go, just to StatCrunch or Excel and try to do a histogram, and you get something like that, this is called symmetric distribution or bell-shaped distribution. And remember, in a bell-shaped distribution, the mean is right in the center of the data set. So we're going to suppose that we have a bell-shaped distribution. And I'm going to sketch it like that. And I'm going to do the bell shape just like this. This is a bell-shaped distribution. And as we said, this will be the mean right here, right in the center, guys. This is the mean. We call it X bar. And the data values, these are the histograms right here, but I'm just going to do the bell shape to give you a feel of what the data set looks like. So you have, let's say, 500 values, and you put them, just into a StatCrunch and try to do a histogram, and it turns out, just something to look like this shape. And this is what we call a bell-shaped distribution. Okay. If I ask you a question, guys, the mean splits up the shape into 2 equal shapes. How many data values will be to the left, or what percent of the values will be to the left of the mean, and what percent of the values will be to the right of the mean? Can you guys answer this question?
About 50%.
Exactly. 50% of the values will be to the left of the mean, and 50% of the values will be to the right of the mean. This is one property of the symmetric distribution. So about 50% to the left and about 50% to the right. Right under the curve, guys, all the values are under the curve. 100% of the values are under the curve. So we get all of them right under the curve. Now, let's say, guys, the mean turned out to be 50, and the standard deviation of this data set turned out to be 10. So we have a data set. The mean is 50, and the standard deviation is 10. I'm going to show you how to scale, those 2 numbers on the number line. We said the mean is right in the center, so the 50 is going to be right here. Now, when you go on the number line to the right, the values go up. When you go to the left, the values go down. Now, I'm going to split this into 3 pieces, and I'm going to put at 10, that's a 60, at 10, that's a 70, and at 10, that's a 80. Now on the other side, guys, I'm going to subtract them because we're going with lower values here. So that's going to be a 40. I just made up those two values, guys. So, and that's a 30, and that's a 20. So it seems to me, guys, like from 20 all the way to 80, we cover almost the entire data set, except for a little bit on the tail to the left and a little bit on the tail to the right. But standard deviation is 10. And the standard deviation, guys, it tells you how far do data values deviate, just from the mean. So this is what the standard deviation is. That's a 10 and that's a 50. So 50, we agree that it should be in the center because the mean is called the measure of center. So the mean is 50. And then it makes sense to, when you go on the number line, to the right, that the values go up and the number go down. Now, probably the question you ask me, why did you label it in such a thing? 50 plus 10 is 60, 60 plus 10 is 70. You will know in a second. So statisticians did some experiments, guys, on data sets that are bell-shaped, that are symmetric. And they came up with the following conclusions, that 68% of data values, I'm going to write it down and then I'll sketch it for you guys. 68% of data values are within one standard deviation of the mean. And mute yourself here. See an echo there. And let me explain this to you. This is one conclusion that statisticians notice when the data set is symmetric. It looks like this. 68% of the data values are within one standard deviation of the mean. Let me tell you what the word within one standard deviation of the mean means. Within one standard deviation of the mean means one standard deviation below the mean or one standard deviation above the mean. If I go one standard deviation below the mean, I'm at 40. And if I go one standard deviation above the mean, at 50. So if I shade those two areas between 40 and 60, I should have 68% of the values of the data set. So this is 68%. Now, statisticians also notice that 95% of the values, almost all of them, are within two standard deviation of the mean. Let's explain what that means. Let me go from 50 and go two standard deviation below the mean. Two standard deviation below the mean, guys, means I have to subtract a 10 and then another 10. So I'm right here. And two standard deviation above the mean, guys, I have to go from 50 to 60. That's one standard deviation. 60 to 70, that's another one. And I am right here. And if I shade all of this area, guys, that turns out to be 95% of the data values. Almost, it captures most of the data set. So that's 95%. Now the last conclusion, guys, that's why we call it the 68, 95, 99.7. Statisticians notice that 99.7% of the values fall within three standard deviation of the mean, almost all of them. Three standard deviations of the mean. Okay, let me tell you what the three standard deviation means, guys. If you go 50 and subtract 10 three times, where would you end up at? 40, 30, 20. This is what I meant by three standard deviation. And if you go from 50 and add three standard deviation, 60, 70, 80. And now if I shade all of this, You can see, guys, it almost covered the entire data set, 99.7%. We're still missing a little bit from 100%. What's missing from 100%, guys? It says 99.7% are captured, but not 100%. What's the difference? Between
0.3.
0.3%. Do you guys have an idea what kind of values are not captured here? What do we call them? These values seem to be way out of the norm,
Would it be
way
the
out to the right or way out to the left. What kind of values are they?
outliers?
Outliers. These are the extreme values that don't get captured by the data set. So when you have a bell-shaped curve, guys, when you have a symmetric distribution, we can say that 60-80% of the values fall within one standard deviation of the mean. 95% of the values fall within two standard deviation of the mean, and 99.7% of the values fall within three standard deviation of the mean. So in real life, guys, it's rare to find anything that goes beyond the three standard deviation of the mean. That will be too extreme, just to happen. It's not going to happen. That's why we can capture 99.7% of the values by going only three standard deviation. We don't talk about 4 or 5 standard deviation because that doesn't exist in real life. I'm going to give you this example. Let's say, guys, I ask you how much money you spend a week on food, eating out. So I get some numbers, just from students. And then 30 students in my class, 30 students give me answers. And I get the data values, I put them in the calculator, and I find the mean. The mean turns out to be, let's say we say a week, let's say the mean turns out to be $45. And the standard deviation turned out to be $8.50. I'll write them down right here. And let's say I try to do a histogram of the values that you guys gave me, and it turns out to be symmetric. It has to be symmetric. That's a condition. In order to use the 68, 95, 99.7% rule, guys, the data, the shape has to be symmetric. It has to tell you that the shape is symmetric. What kind of conclusion, guys, I can make? Watch. What I like you to do, guys, first of all, to subtract 8.5 from 45 and add 8.5 to 45. Can you do that for me? What is 45 minus 8.5?
36.5.
36.5. And add 8.5 to it. 53.
3.5.
All right. Look at the first conclusion I can make, guys. 68% of students spend between $36.50 and $53.50 on food each week. Where did I get the 68%, guys, from? I didn't make it up. I just added one standard deviation and subtracted one standard deviation. Added 8.5 and subtracted 8.5. Now I want to do a conclusion for the 95% of students. Spend between, okay. What we're going to do with those two numbers, guys? We're going to subtract another standard deviation from this and add a standard deviation for that. So 36.5, guys, minus 8.5, it's going to be $28. And 53.50, add 8.50, it's going to be $62. on food each week. Let's do the last one. 99.7% of the students capture, almost all of them, spend between. Okay, for the 28 guys, we need to subtract another standard deviation. And for the 62, we have to add another standard deviation. So 28 minus 8.5, it's 19.5. You see how the gap widens when we go 3 standard deviation because we get a bigger portion of the curve. And 70.50 cents on food each week. This is what we call the empirical rule. It applies to histograms that are symmetric. And if you ask me what kind of questions you will see in the homework when you do this, I'm going to show you an example right away. So I'm going to go back to my handout right now. Resume record. So here's the summary, guys, for the rule. Let me just show you the summary. Approximately 68% of the observation fall within one standard deviation of the mean. 95% of the observation fall within 2 standard deviations of the mean, and 99.7% of the observation fall within 3 standard deviation of the mean. And as I asked you guys what happened to the 0.3%, one of you said these are the outliers, and I 100% agree with this. Okay. Let's look at this example, guys. 500 juniors at Central High School took the ACT last year. The scores were distributed normally. Okay, let me tell you what the word normally means. Bell-shaped. That means bell-shaped. Once it says bell-shaped, guys, then the 68, 95, 99.7 rule applies. With the mean of 22 and a standard deviation of 3. Label the mean and 3 standard deviation on the curve. So the mean, guys, you agree with me, it should be here. That's the 22. That's the mean, the center. Okay, can you guys help me label those 3 tick marks here? He said the standard deviation is 3. So can you tell me what the numbers are going to be, please? Go ahead. 22 plus 3 is what?
25.
25. 25 plus 3 is?
28.
Yep. And then 31. Now go down. Now go backward, guys. So you subtract. 22 minus 3 is 19. And that is a 16. And that is a 13. And now, guys, I'd like you to participate with me in answering, just the questions. What percent of the values are between, I'm going to change them a little bit. Yeah, 16 and 28, that's fine. Let's leave it. 16 and 28. So I want, what percent of the values are between 16 and 28? What's the answer, guys?
95%.
95%. Does everyone agree it's 95%? Because look, from 22, we count 2 standard deviation, we get to 28. From 22, we count 2 standard deviation below, we get to 16. So it is 95%. Done. These are the kind of questions you're going to see online. You just look at it, observe, and put the answer. But you need to know the rule. 68 for 1 standard deviation, 95 for 2 standard deviation, 99.7 for 3 standard deviation. What scores are between 19 and 25? I'm going to change it to 25 here just to make it easy. 19 and 25, guys. Let me just sketch it. Answer?
68.
68, yes. 68, that is correct. What percentage of the scores are going to be between 16? I'm going to change this one to 22. This. A little bit tricky, but it's not difficult.
Would it still be 68?
68 is 19 to 25. Can't be 68 here.
50?
Well, 50 has to be from 22 all the way to the end because 50 is half of the curve. And the middle is 22, so it will be 20. So it has to be less than 50, guys. How
It's-
much less? What is it exactly?
34.
Not 34. I know why you said 34. You divide 68 by 2, but you're getting very close. Okay, what's 16 to 28, guys? What did we say 16 to 28 is what? 95, correct? Well, guys, do you agree with me that from 22 to 16 is 2 standard deviation below the mean? And from 22 to 28 is 2 standard deviation above the mean. Since 2 standard deviation below the mean and 2 standard deviation above the mean together will be 95%, what do you think the red one is going to be worth? It's half of what? The 95%. So it's 95% divided by 2. Because look, from 22 to 16, I count 2 standard deviation going down. Or from 22 to 28, I count 2 standard deviation going up. Both, they make 95%, but I want only half of it, so it will be 95% divided by 2.
So 47.5?
That is correct. 47.5%. All right. Let's see.
Is 1 standard deviation 68?
Yes, but it has to be below and above. So from 19 to 25, it's 68, exactly. But if I ask you guys from 19 to 22, it is only 1 standard deviation below. You don't do 68, you just do 68 divided by 2, which is 34%. That's what the student says earlier. And if I ask you what percent of the values are between 22 and 25, think about it. How many standard deviations is this? It's 1 standard deviation above the mean will be 68 divided by 2, which is 34%. Okay, let's look at D, guys. What percent of the values are less than 13? Right here. It looks very, very small right here. Who can figure this out? It's going to be a very, very small percent. Very small, but we can find it.
Is it 0.15 or no?
Good, very good. Very good. And let me tell you why she says 0.5. You guys know 99.7% of the values are within 3 standard deviation. Let me show you what the 99.7% are right here. Everything until I get to these. So 99.7%, guys, is 3 standard deviation within the mean. 3 standard deviation will take us 19, 16, 13 up to here. And 3 standard deviation above the mean will take us up to here. So you guys, where the 2 lines are standing up, we have 99.7% of the values. Let me just show you. So this is from 13 to 31, guys, I have 99.7%. What's left for the tails? From here onward or from there backward, just going down. 100% minus 99.7% will be 0.3%. But remember, guys, the 0.3% is split up between the tails. So this one has half of 0.3%, and this one has half of 0.3%. If you take 0.3, guys, and divide it by 2, it's going to give you a 0.15%. And this is why it is 0.15%. It's half of this. What percentage of the scores is, I'm going to change this one, is between 19 and 22? (19 and 22). That should be easy, guys. Ask yourself, how many standard deviation from 19 to 22?
3.
It's 3, which is 1 standard deviation, right? So what would be the answer? What percentage of the data values are between 19 and 22? We know from 19 to 25, it's 1 standard deviation within the mean, which is 68%. From 19 to 28, it will be what?
Would it be 34%?
What is it?
34.
Not 44. You mean 34? You meant 34?
Yes.
34, yes. 68% divided by 2. Yeah, look, guys, from 19 to 22, I only have 1 standard deviation. The difference between 19 and 22 is 3, and the standard deviation is 3. Once you get 1 standard deviation, it's 68% divided by 2. If you get 1 standard deviation below the mean. Now, let's say, guys, in the homework online, he asks you to find what's the percent of the values between 22 and 25. Will be the same thing, 34%. Because from 23 to 22 to 25, it's also 1 standard deviation above the mean. Whether it is above the mean or below the mean, it's the same thing. 34% goes above and 34% goes below to give you a total of 68%. So this is what we call the empirical rule, and it only applies if you have a shape that looks like, a symmetric shape. For your information, guys, in real life, most of the data sets that we collect, when we try to sketch them, they will turn out to be very much like bell-shaped. Bell-shaped means all of us have very common characteristics, so we come close together. There will be a few of us who are on one extreme and very few of us who are on the other extreme. But the most of us are belong, just together. And this is what this graph tells you. The majority of us are here. There are a few of us who go to the right extreme, and some of us will go to the left side. But the overwhelming majority is right here, and this is what a symmetric shape is. I have another example I'm going to do with you guys. Let's do this example together, and that should wrap up section 2.4. The scores for all high school seniors at POP taken the verbal section of the Scholastic Aptitude Test, the SAT, in a particular year had a mean of 490 and a standard deviation of 100. So the mean, guys, is 490 and the standard deviation is 100. The distribution of the scores is bell-shaped. He says it is bell-shaped, guys. Draw the normal bell-shaped curve to support your answer. So let's draw the curve first of all. So I'm going to do this on a separate sheet of paper, and then we'll answer the questions together. You do this, then you do that, and you put the mean right in the center, which is 490. And he says the standard deviation, guys, is 100. So let me just scale this 3 tick marks to the right and 3 tick marks to the left. Okay. So I got the sigma is 100. So you guys agree with me, I should add 100 every time. So that's 590, 690, and 790. And now I'm going to subtract 100. I don't think on the set anyone can score below 200 anyway. So this is the normal, the bell-shaped curve, guys. And now we're going to answer some questions. The first question: what percentage of the scores are between 390 and 590? You should easily answer this question, guys. What percentage of the scores are between 390 and 590? Who can give me the answer?
60.
Remember 68, 95, 99.7%. So I heard the students saying 68. Let's see in the chat. Yeah, 68%. That is correct. Done. You don't do any work other than this. One student scored 795 on this test. How did the students do comparing to the rest of the scores? So 795. Let me show you where the 795. Right here. Ooh, that's 795. Okay, can you tell me, guys, how did the students you think did compare to the rest of the class or the other students? Any comments here?
Will he be considered one of the outliers?
That means outliers on the good side, right? Because he went way to the right. Probably he is the only student he is the one who scored the highest score beyond, just all other students. Yeah, it is an outlier. It's a good outlier in this case. You guys, you want to be an outlier when you take this test and score so high. So he's almost get the perfect score, which is 800. Now it's 1600, but it used to be, used to be different scaling. So I would say probably the top score, the highest score. All right, let's see. C, I'll show you the sketch once we read the question. A rather exclusive university only admits students who were among the highest 16% of the scores on this test. What score would the students need on this test to be qualified as a top 16%? Okay, let's see what the top 16% would be. So here's the sketch, guys. They said the top 16% of students will be admitted to the school. So we know we're at the 50% right here. You guys agree with me that the middle is 50%. And we know this is a 34% and this is a 34%. Right here. So what percent would that number represent? If this is a 50% and this is another 34%, what this number represents, guys?
84%.
Exactly. And if this is 84%, what's left for this area to get to the 100% as we go from left to right this way? How much a percentage we are away, just from 100%? 16%. So these students, guys, who score 590 and higher are the top 16% because this area is 16% right here. So how would you answer the question now as I told you that this is 16, remaining 16%? What should the students score in order to be considered a top 16%? 590 or what?
Higher.
Or higher, exactly, and that would be answer the question. If it was the bottom 16%, guys, which is not the question here, if it was the bottom 16%, it would have been, it would have been this 390 and lower, but he is 590 or higher because that's the top 16%. Okay, the last part. And I'm just gonna put the graph in there, guys, since I'm gonna scan this document later. So I'm just gonna put it right here. Just draw a bell, put the mean right in the center, which is, we said, 490. And then scale it. 3 tick marks, guys. Make sure the last tick mark takes you to toward pretty much the end of the tail. 590, 690, 790, and then 390, 290, 190. Okay. The last question. The senior class at Pope has 450 students and offers a $500 scholarship to everyone that goes above 690. What percent of the students will get the scholarship? Let's go to the graph. So any students, guys, who go above 690, right here, will get a scholarship of 500. 690 and up. What percent of the students will get this scholarship?
Would it be 8%?
Well, let's see. What you did, you split up the 16. It doesn't work this way because the curve is not like straight shape. Look, there's too much area here and there's little bit of area here. So it wouldn't work, just this way. Here's how we're gonna do it. Watch. This is 2 standard deviation. And this is 2 standard deviation. What percent of the scores fall within 2 standard deviation of the mean, guys? It's 95%. Do you guys agree that 95% is 2 standard deviation? So this is a 95%. Let me sketch it for you. You're going to be surprised with the answer. It's a lot lower than 8%. So the red area, guys, is the 95%. How much is left for this and that from 100%?
5%.
5%. Split it up on 2 sides. If you split it up on 2 sides, this side will get 2.5% and this side will get the 2.5%. So actually the answer to this question is 2.5% of the students. These are students who went about 2 standard deviation above the mean. So it will be 2.5%. To wrap this up, if I give you the first test, and I will try to talk to students about their performance in the class, and I tell one student that your score was 2 standard deviation above the mean. Should the students be happy with this announcement? What do you guys think?
Yes.
Definitely yes. You are 2 standard deviation above the mean. You're probably one of the top scores in the class. If I tell a students that you are 1 standard deviation above the mean, should the students also be satisfied? Indeed, yes, because you are above the mean and you're 1 standard deviation above the mean. So this is not bad at all. But if I tell a students that your score on the test happened to be 2 standard deviation below the mean, should the students be concerned?
They should be concerned.
Exactly, should be very, very concerned because that means probably the students got the lowest score, one of the lowest score on the test. You don't want to go below the mean, guys. If I tell you you're 0.5 standard deviation below the mean, Yeah, you should be concerned because you are up below the mean, but you're not too far below the mean, only 0.5 standard deviation. The more standard deviation you are below the mean, guys, the more concern when it comes, just to test scores. If I tell a students that your score is 3 standard deviation below the mean, I can tell you this score is going to be the lowest for sure. You can't go 3 standard deviation below the mean. I mean, when you guys talk 3 standard deviation below the mean, you're here, way down. And as I told you, even on the set, nobody gets 190. The lowest score is 200. So this is very extreme when you go way below the mean. If I tell a students you are 0 standard deviation from the mean, what is it that I'm trying to tell the student?
They're at 50%.
You're exactly at the mean. Your average is not 50%, but you are right at the mean. Your score is exactly the average. So if I tell you you are 0 standard deviation from the mean, that means your score is exactly the mean. So if the mean of the class was, let's say, 78, that means your score was 78. Now, if I tell you that the average of the class was 78 and the standard deviation was 10, and if I tell the students your score was 1 standard deviation above the mean, it's easy for the students to figure out her or his score. You just take 78 and add 10 to it, it will be 88. But if I tell the students your score was 1 standard deviation below the mean, also it is easy for the students to figure out the score. Just take 78 and subtract the 10. It would be 68. So below means a minus and above means an addition. And when it comes to scores, guys, it's always good to have a plus rather than having a minus. Okay, so that concludes section 2